All right, guys, a continuation from yesterday, finding limits numerically and graphically, part 2, a little bit of an extension from yesterday. First of all, we're going to be talking about one-sided limits instead of, yesterday all the limits we looked at was a graph or a function approaching a certain number from both sides. Today we're going to look at one-sided limits where it may approach two different numbers from each side. Like for an example, we looked at this yesterday in a video, the same problem. This is a piecewise function where if you look at approaching to the left, if you're approaching 0 from the left side, the graph's getting closer and closer to 0. That's why that first limit then says if you look at the notation, it says from the negative side, it's approaching 0. But if you look at it from up here, it says it's approaching 0 from the right side or from the positive side of 0, it's getting closer and closer to 1. So those are one-sided limits because you're just looking at one side of the graph approaching a certain point instead of both sides of the graph. All right, definition. We write this right here. The limit as x approaches a from the negative side of f of x equals L. And the way you say the left-hand limit of f of x as x approaches a, or the limit of x as x approaches a from the left, and the left, because there's a minus sign, is equal to L if we can make the values of f of x very, very close to L by taking x sufficiently close to a and x is less than a. So x must be less than a because you're approaching it from the left-hand side. The only thing, and I wrote this sentence down here, the only thing that is different from yesterday in that definition is x must be less than a. So because we're approaching from the left-hand side, because of that minus sign, we're approaching from the left, so x is going to be less than a all the time. So we're just looking at the values of x that are less than the a. If we said x is greater than a, we'd be approaching from the right-hand side and looking at the right-hand limit. It'll look like this. The only difference is it'd be a with the plus sign, which is saying that you're approaching a from the right-hand side instead of the left-hand side. All right, so here's what we got three things here. Really, this is what we did in the previous video. The limit as x gets closer to a, and if you just see the a like that, it means from both sides equals L. Now that's true only if you approach it from the left and you're getting closer and closer to the number L, and you also approach it from the right and get closer and closer to number L. If these are not both true, that's not true, okay? To do limit just of a number, x approaches a number to get L, it must approach the same number from each side. Let's take an example from a graph here. This is probably, I don't know what kind of graph this is, probably piecewise, something like that. But let's look at part A right here. Part A says limit as x approaches 2 from the negative side or from the left. So if I'm coming closer to 2 from the left, I need to change colors there. I'm coming up here and I'm getting closer and closer to 3. So that value would be 3. The second part says limit as you get closer and closer to 2 from the positive side. So here I'm getting closer and closer to 2 from the right, and I'm getting closer to 1. Now because those numbers are different, that right there does not exist. D and E does not exist. The limit as x approaches 2 because you get two different values. Remember, for that to exist, for a limit to exist as x is approaching a number, you must be approaching the same number from both sides. Okay, let's look at the part B right here. Part B says limit as x is approaching 5 from the negative side. So 5's right here. If I'm going to get closer and closer to it from the left, I'm getting closer to 2. All right, then if you approach 5 from the positive side, or the right side, so I'm coming this direction, getting closer and closer to 5, also getting closer and closer to 2. All right, so now I can do this. Limit as x approaches 5 is also going to equal 2 because it's getting closer and closer to 2 both the left side and the right side. Now, the weird thing about that function is actually the value at 5 is actually down here at 1. So that doesn't really matter what the actual value is as right now as much as what the limits are, what you're getting closer and closer to as you approach it. Okay, one more example here. This is a piecewise. Let f of x be the function defined by this piecewise function. And we got to find three things. We got to find the limit of f of x as x approaches 1 from the left. So if I'm coming from the left and getting closer and closer to 1, the graph is getting closer and closer to 2. Now look at this part. It says the limit of f of x as x approaches 1 from the right. That's this way, and coming closer and closer to 1. What's the graph getting closer and closer to? 3. So what does that mean about this? The limit of f of x as x approaches 1. Because it's approaching two different numbers from the left and the right, that limit does not exist. Not all limits exist. All right, hope that makes some sense today. Not too bad. We're going to continue tomorrow with a little bit of what we did in class today or yesterday, along with the new one-sided limits also. So we'll work on it. See you then. Bye.